Oh, there we go. Okay, so hello, I'm Tom Akehurst, for those of you that don't already know me. I work with Energize Work with Gus. We are a business technology consulting company. Have I got that right? Yeah, more or less. We deliver, we build bespoke software for our customers, and we do consulting on how to get better at building software. We're long-time users of sort of agile practices, lean startup more recently, continuous delivery and DevOps, and sort of Tom Gill's competitive engineering stuff. Just give a quick overview of what we're about. So as a consulting company, we have the kind of project that we like doing, where you can you get in there early, you get to influence the right people at the customer. They understand the value of delivering iteratively, of investing in capability and capacity and all that kind of stuff. This talk is about the other kind of project. So it's one that we worked on recently, where we got brought in late to fix something that was going horribly wrong, where another team had sort of failed to make much progress, where we didn't really get much face time with the people who could really change things, where lots of things about the way it was organised was kind of unamenable to continuous delivery and generally to being able to do software delivery well. So to elaborate a little bit on that, it was a huge program, lots of people involved, and when you have lots of people, you have to subdivide them into groups somehow. And what they'd done was kind of subdivide people by technical slice. So that's pretty problematic, and I'll go into that in a bit more detail a bit later on. A lot of the suppliers involved were on fixed price contracts, so there was a kind of lack of flexibility in some of the groups that we had to interact with. They had separate teams with DevOps and testers in, which creates additional sets of problems. Putting people in silos that really ought to be kind of integrated with the stuff that you're doing is generally kind of a bad idea as well. Does everyone know what sort of Theory Y and Theory X are of management? Has anyone not heard of those? Okay. So there are a sort of pair of kind of characterizations of management styles that have been around since the early 20th century, I think, where Theory X is based on the idea that people are essentially kind of lazy and unmotivated and need to be extrinsically motivated through fear and coercion and that kind of thing. And Theory Y is about kind of understanding that people can be intrinsically motivated to do well at their work, and if you create the right environment and right conditions, then they'll do good work without you having to stand there with a big stick. So this was more of a Theory X place, I think it's fair to say. And the net effect of that is that people are very risk and change averse. People want to do the things that are least likely to get them punished by somebody, rather than what might turn out to be beneficial for the project. So there's a lot of that to contend with as well. Process-wise, they kind of said they were doing agile, but it left a lot to be decided according to sort of our view of what constitutes a decent agile process. General lack of feedback. I think this is partly this kind of risk and change aversion thing. Nobody really wanted to change things once they seem to be working well enough. A lot of the sort of enabling technical practices that you really have to do in order to be, to do agile well, so TDD, refactoring, CI, that sort of thing, were either not done at all by, the other teams involved in this, or done badly. So there was a kind of CI theatre whereby everybody had a branch that didn't, was just like there on its own with a CI server happily building it and going green all the time. But actual integration didn't happen all that often. So there's a bit of that. Live releases were months or even years apart in some cases. So there were lots of work in progress used to build up. Lots of unvalidated stuff would accumulate. The true cycle times, the cycle times to get things that actually mattered done, like getting stuff out in front of users, were incredibly long. But nobody was measuring that, so it kind of went unnoticed. There was a sort of fixation on velocity instead, and the way you could kind of appear to be generating velocity was to kind of atomize everything down to these tiny meaningless stories that were one small chunk of a feature inside of one layer, and that kind of meant that these things were flowing across the board, but they weren't adding up to to anything that you could release or test or do anything interesting with. Sorry, excuse me. So I've managed to mess my slides up in such a way that I can't read my presenter notes. So do you mind giving me a moment while I sort that out? That's better. So technology-wise, it was the good old-fashioned sort of early 2000s. Massive J2E containers that use 2 gigabytes of RAM before they've even started. There was this kind of old-school SOA and everything was written in kind of those BPM diagrams rather than people actually writing code. This made it all very hard to test and deploy. This separate DevOps team who are often in another room were kind of charged with integrating this stuff with sort of slightly more modern automation tools, and they were clearly having a horrendous time trying to do this because all this stuff was conceived of in the sort of pre-automation era. So that made life very difficult, and there were things it was supposed to make easy that actually also turned out to be complex. So there was we were asked to put SAML security on there as a means of kind of passing the security principle around between layers, and they kind of said, well, it's dead easy to do it in the SOA layers. We just tick a box and it's switched on and that's it. That's all we need to do. But you guys are going to have to write some code, aren't you? Because there's no you don't have anything in your code base to do SAML. So we spent about 8 or 10 hours maybe at most sort of figuring out how to add that in, and deployed it, and that was it. And then everybody else spent 4 weeks playing whack-a-mole with this what turned out to be 200 tick boxes to enable SAML everywhere. So that was we probably laughed about that more than we should have done, really. So obviously there was soap everywhere, and I think we all pretty much hate soap. I mean, hopefully I'm preaching to the converted in terms of soap being a bad choice these days. But I won't elaborate on that too much. I think Joe Walnes has summed it up there very nicely. I'll talk a little bit more about what it's sort of why soap is a bad thing for continuous delivery specifically a bit later. But finally we inherited a code base from this previous team. Fortunately, it wasn't very big because they hadn't made very much progress, but there was some of it, and there was sort of politics around it. We couldn't just throw it away. We had to be seen to be salvaging something that this team had done before, so that the kind of accumulated story points they'd earned didn't go back to zero again, because that wouldn't have been good. So we kind of got some refactoring time at the beginning, but nowhere near enough. And we had to sort of live with the legacy of that for the first bit of the project, which wasn't much fun.
You kept all of the characters just in a different order.
Yeah, that's probably a good name for it, actually. There we go. We've invented 2 new terms this evening. Unfortunately, I can't say who this was for or what we were building or anything like that, because we were sort of sworn to secrecy for a number of reasons. So I can't give a detailed architecture, but to give an overview of the architecture, it had a database. It had an ETL process that put things in the database. And then it had some SOAP services, and some more SOAP services, and some more SOAP services. And then finally there was a thing that we were building on the top, which was this kind of UI that was supposed to make sense of all this stuff going on underneath. There were 4 different dev teams working on all this stuff, and then plus the separate sort of DevOps and test teams that were involved in it as well. So this was kind of 6 teams of people all hammering away at this kind of endless mesh of SOAP services. Needless to say that that didn't simplify things perhaps to down to the core that they might have been. I'm going to abuse the term pipeline now because I don't think you could really call it a pipeline, but there was a series of stages, a gauntlet, if you like, that the code that we wrote had to run before it got anywhere near a production environment, and that was tricky. We didn't have a pre-test integration environment at all. We had no way of testing our code against anything that anyone else had done before it landed in an environment that was kind of owned by a bunch of manual testers who were very sort of stressed and overworked and red in the face a lot of the time, and who, if you blew their environment up, they'd come over and stand there threateningly behind you. So that made life pretty interesting. The environments were generally so locked down you couldn't even get an HTTP connection to the web server in them. You had to build 2 SSH tunnels to get there. which obviously was a real boon to productivity. And there was kind of there was this sort of release testing cube thing. There were 3 test environments that got more and more realistic, but were kind of further and further away from us as they got more realistic. And each of them had a separate group of testers on it, and the first group communicated with us quite well because they were sitting next to us. The other group were over the other end of the room, so they occasionally deigned to wander over and talk to us about stuff, but not particularly often. And we never did find out where the third group were. They used to just log JIRA tickets and assign them all to Gus. I think somebody must have pranked Gus, because it was always Gus, it was never the rest of us. So you usually get this, it broke, kind of that level of detail. Part of the consequence of all this as well is that there had to be a sort of single build master guy who kind of brought all this together. One of the downsides of having SOAP services everywhere is that you end up having to kind of promote them all in lockstep with each other. You can't really loose couple them very, very effectively. So you need someone who understands which version of what goes with what, and who sort of puts it all into an environment. So this guy was working 70 or 80 hours a week, and unsurprisingly he was off sick a lot as well. So that didn't help either. That was another source of bottleneck. And then finally they had the classic anti-pattern, which is the Selenium automation team, who just take verbatim everything that the other testers do and transcribe it into an automated test, which can only run once a day because it takes 6 hours or whatever, and where it's half of it's guaranteed to fail, and all that kind of good stuff. So this is the environment we came into, and you might argue that we might have been within our rights just to kind of say, well, this is just the way it is. There's not a lot to be done with this. We can't influence people to change the system, so we'll just do the best we can within it and get out as quickly as we can. But in spite of all that, we kind of thought, well, what can we do? What's the best that good can look like in these under these circumstances? I'm sure there's a more succinct way of wording that, but anyway. This project was failing, and they basically wanted features delivered. They wanted us to catch up. So within that kind of narrow definition of success, we thought we can still do something with this. But in order to do that, we want to apply all the usual principles. We need to keep our own cycle time down, but without locally optimizing, without negatively influencing the whole. We want to try and manage down the sort of quality, particularly the quality risks that we can own ourselves, and at least try and influence the ones that we can't directly, even though a lot of stuff is kind of beyond our borders. We still want to make sure that we're not actively harming processes downstream from us. And finally, just don't compromise on quality. Don't compromise on don't make the same compromises that everyone else is making just because it's okay to do so in that environment. So with all that in mind, we sort of, set about figuring out what practices were going to work for us, and all the obvious basic stuff, the continuous delivery 101 stuff, definitely helps a lot. I mean, hopefully this is all bread and butter stuff to everyone in the room, so I don't really need to elaborate on it. Is there anything here which is not a familiar term, or something that needs elaborating on at all? No, good. Acceptance test-driven development. So yeah, just driving the application from the outside and writing kind of business-focused tests rather than kind of code-focused tests, if you see what I mean. So a few other things that we did, which turned out to help a lot. One of them was service mocking. So we essentially this means kind of being able to isolate our application completely from all its dependencies for development and testing. Obviously because we didn't have an environment to work in at all, we had to do something. We needed some way of making progress. So this was kind of essential really before we could even get started. But what it enabled was us to do fast functional testing, much faster than if we'd been sort of testing down the entire stack. It meant actually that we went a little bit against kind of CD orthodoxy, and we had kind of everything all in our commit build, rather than splitting it out into sort of unit tests and functional tests in a second stage. Part of the reason for this was this inherited code base that we had, particularly at the beginning, was pretty difficult to test, and we ended up relying more than we would have liked to really on the selenium test in order to sort of keep us honest. So we didn't really want to split those two up and allow the selenium suite to get out of control in terms of its build time. So we kept that in our on commit build. The other advantage of mocking is you don't have to wait for other teams to deliver things before you can start work. You can sketch out a few kind of example messages between the systems, and then both teams can go off and start working, and you get rid of a fair amount of schedule risk that way. As I mentioned, it reduced the need, at least for an integration environment. Didn't eliminate it. There were still plenty of reasons it would have been good to have one, but certainly it meant we could at least make progress. The other thing it lets you do, and this is probably the subject of a whole other talk, but it making real or sort of realish systems behave badly kind of on demand is quite difficult. If you want timeouts or service unavailable responses or sudden socket disconnections and all that kind of stuff that will definitely happen at 3 a.m. when you're asleep. Making that sort of thing happen on demand isn't always that easy. So the advantage of service mocking is that you can emulate that behaviour and you can find out ahead of time how your application is going to behave when you do that to it. To do all this, we used wiremock. I have to pimp this whenever I do a talk because it's a tool I've been working on for about 4 years or so now. Essentially, it's a sort of Mockito-like library, but it runs up a web server and allows you to stub and verify HTTP calls, as I say, inject faults, create kind of stateful scenarios, that sort of stuff. And so we basically created test doubles for all of our SOAP services using this, actually embedding it directly into the application. So you started the app and it would start up with its embedded SOAP services, and then you could configure them programmatically or with kind of pre-canned data. To generate the data, we used a tool called sham, which is a thing written by an XEW guy called Tom Dunstan. Sham basically generates kind of random but realistic-looking data in various classes. People or addresses or kind of mark-off text for articles and all that sort of stuff. And there's a number of advantages to sort of generating random data as a matter of routine rather than kind of hand cranking it, which is what I've tended to do in the past. So you end up with the same sort of hard-coded stuff, or something that goes John Smith 1, John Smith 2, John Smith 3, and so on like that. Generating stuff randomly, first of all, it gives you, your demos are better. So demos kind of look like this when you do it the usual sort of lazy way. You have a bunch of stuff which is obviously fake, and a stakeholder glancing at this is going to go, well, that doesn't look right at all. Switching to sham data, you get something like this, which actually looks realistic. And every time you generate the data, you get something different. So you kind of avoid the kind of ruts that you get into as a developer when you're testing your own stuff. I find if you've got static data, fixed data that you rely on being there, you end up taking exactly the same path through the app every time. You use the mouse and the keyboard in the same way and all that kind of stuff, and you end up completely blind to things that are actually badly wrong with your app that your testers then embarrass you with after you've released it. So the advantage of the data moving around and so on like that is it keeps you on your toes a little bit, and you discover things that you might not notice otherwise. The other advantage is when you're doing automated testing, you can kind of test in a more generative style. So rather than again sort of setting up text fixtures with static data, you're kind of varying it on each test run. And much like with your manual testing, by doing this, you accidentally discover useful new things about quality problems in your code that you wouldn't necessarily trip over otherwise. So we kind of started out, this is the kind of test case that we might have written, without using sham. As I say, where you set up a static fixture and then you go and load a page and then you sort of assert stuff about it. But we ended up with most of our tests looking a bit more like this, where you don't see the data at all. You see assertions against the original data that was generated. Sham does have a feature which we didn't get around to using in the end, but you can pin the random seed for it. So if you have a test run that fails because of some particular combination of data, it will spit out the random seed that it used, and then you can use that to get an identical test run the next time if you pass it in as a parameter, which is, I guess, quite handy. But yeah, again, you can you can have all sorts of fun with this. You can generate. So I loaded in a load of Sri Lankan names because they're always incredibly long. So we ended up with names that were screwing up the layout horribly. Whenever you looked at it in the browser, which is something you often miss with your John Smith 1-2-3 approach. So putting all that together, the setup kind of looked like this. This would all sort of run, straight out of the build tool on a laptop. So boot the app up with an embedded WireMock for soap stubs. Drive tests through sort of Gem and Selenium and Phantom.js, which is pretty typical stuff. And then, as you saw in the previous code sample, you'd be driving sham through a bunch of templates that would generate the XML for the soap responses. We found that good practice is always, always set the data up locally to your test. Don't set it up somewhere else. I think one of the ways we tripped ourselves up at the beginning was we had this kind of big data seeding class that would sort of kick off at the beginning, and very quickly it became a huge pain to figure out. Why is this test failing? Oh, it's because of this piece of data that got loaded 10 minutes ago over here. So yeah, making sure that the kind of setup and teardown of data is close to the actual test cases that you're writing seems to be a good idea. Is there any questions on that so far? Does that all make sense? Is that incredibly boring? So I mentioned earlier that there was a lot of soap involved in this, and that wasn't a good thing. The reason soap is difficult for sort of multi-team projects where you're trying to iterate rapidly and work somewhat independently from each other is the real problem in there is WSDL, and the way WSDL is used by most of the sort of soap tools out there. So the typical approach is generate a WSDL document, which is a completely sort of 100% defined schema for a data structure, and then you generate your code from it. And the code generator doesn't know which bits of that code you're actually going to call, which bits of that data structure you care about. So it generates the whole thing, and then that becomes this maximally coupled contract with the service that you're talking to. But you don't have to do SOAP with WSDL at all. You can just treat it sort of almost like REST, but without using any other verbs, where you're just kind of constructing XML and passing it to and from the server, and that can give you a little bit of wiggle room. So we ditched the sort of Axis or CXF or whatever it was that was in there originally, and we switched to this Groovy WS Lite library, which is a really simple, just kind of sticking an XML builder to send stuff, and then a slurper to get it out again. If anyone's familiar with Groovy, exotic names for parsers and builders. What this allowed us to do was to implement a tolerant reader pattern around the stuff that we were consuming, and that gave us a little bit of wiggle room, sort of relative to service teams. It meant that we could often run a little bit ahead, or they could run a little bit ahead, and things would kind of remain compatible. We weren't always broken when we went a minor version of the contract out relative to the services we were talking to, which was kind of handy, really. It sort of it meant that stuff spent less time queued up behind this poor build manager who had to figure out what was compatible with what. Interestingly, we ended up coming to the conclusion, I think, that WSDL or IDLs in general aren't totally evil. That actually there are some okay places to use them, and we ended up writing these kind of policy-based unit tests that where we could sort of selectively validate things within our CI build, rather than it happening kind of out in the environment when it was running. So things like, because we had to send strict, the server was never going to be a tolerant reader, so we'd have to send sort of strictly formed XML to the server. So what we do is go through and generate an example payload for everything we sent to the server, and then validate it against the WSDL in a unit test. And that would really quickly detect the service teams kind of checking in new WSDLs and not letting us know. Or they used to quite often spell things wrong, and then they'd surreptitiously check in a sort of spelling fix, and it would blow everything up. So this was kind of helpful with that, and it was also good for validating our mocks as well. So the problem with mocking stuff is that you can, your mocks can drift away from reality, and this was a good way of kind of keeping, some kind of having some kind of assurance that we weren't doing that as well. So I think don't throw the baby out with the bathwater on IDLs. Using them for stuff like that's okay, but generating code is the real evil of that sort of thing. So another thing we did was, I've got to give a bit of, this is kind of where the title of the hostile planet bit of the talk title comes from. Because we had this sort of crazy running the gauntlet of sort of further and further away test environments that we were sending this thing out through. Gus is a man of many metaphors, and his metaphor for this was it's like building the Mars rover. You know, we're covering it in every piece of instrumentation we can think of, and then sending it millions of miles away into a hostile planet. It's kind of what it felt like, you know, and it'll come back in pieces kind of 3 weeks later. Really, all this was a kind of admin UI, and you know, we put a load of stuff in so you could change bits of configuration on the trot. The main benefit of this actually was for the testers. So I talked a little bit about how we would sometimes kind of do things that lengthened our own cycle if it helped processes downstream, and the testers were a real bottleneck. You know, their environments were flaky, and they always had a huge queue of stuff in front of them. So we'd actively try and do things like this. You know, so being able to shorten the session time out. So rather than waiting for half an hour to find out what happened to the app when your session timed out, you know, they could do it in 5 seconds instead. So there was a bit of that. There was a SOAP request and response history, which was probably the most useful thing out of anything really, because when you're the UI team, you're always the first person to be sort of asked to triage something. You know, when an exception's thrown, it's like, oh well, it's their fault. I saw it in the UI, so it must be the UI's fault, and you get dragged over, and then you trawl through some log files, and you do some other digging around, and then eventually you realise that it was something kind of down the stack somewhere that caused the problem, and we got pretty sick of that pretty quickly. So we put this thing in there, and first of all, that quickly allowed, when we were being asked to triage, we could just say, okay, go and find the first red SOAP interaction. You know, so we marked the ones that were faults in red, and then go and look at it and read the error message, and then we'll figure out who done it, and. Eventually the testers started doing this themselves, and they got a reasonable sort of idea of what which error messages corresponded to which teams. So we got left alone a lot more after we put that in, which was nice. We stuck in the CodaHail drop wizard metrics library. There wasn't really a lot of performance testing going on, which worried the hell out of us. So we kind of thought next best thing, if we at least put some performance instrumentation in there, then we can go and look at it occasionally while testing's happening, and get some idea of what the really egregious bits are. So we had this kind of this view of performance as well, and kind of worst offending calls that were being made, and bits of the app that were running and so on like that. So that was kind of handy in chasing down the really painfully slow bits. We had this service check that was really actually a kind of extension of this WSDL testing thing. So it was going through and again checking that the deployed services that we were using kind of married up with what was on the server, and that would again occasionally. Actually, it was quite often the bits of SOAP would fail to deploy, and then this would show us when that had happened, because it wasn't obvious within the kind of this enterprise console that they were deploying stuff through. So again, that was kind of handy for sort of quickly saying it's just not even there. So that was kind of sorry, I've got these in totally the wrong order, haven't I? So that was our service check. The other thing was scenarios, and these were actually integration tests that were embedded inside the app. So you could stick in a bunch of database IDs and press a button, and it would run through a bunch of kind of sort of interactive kind of transactional scenarios, but calling through the code that we used to get at the services. So that was kind of exercising the semantics a little bit, and that was good when we could use it. But the database data was usually so messed up that in practice all it would throw up is the fact that half the data was missing rather than anything useful. So I think that was a nice idea that maybe goes in the next time if we can generate our own data bin.
I have a question there.
Yeah, sure.
SOAP request response history, is that something, is a tool which you develop on your own, or is it?
Yeah, we developed this ourselves. What it was doing was it had a sort of bounded queue in memory, and it would just pop things into the queue whenever they happened, and then we just had a UI that just spat it out.
Some sort of container, or?
It was just doing it in memory. So we had a SOAP client kind of at the bottom of our UI app, and all it was doing was intercepting the call down to that and then sticking it in the queue. Yeah. So it'd record the request and the response, and as I say, if the response was a SOAP fault or a timeout or whatever, then it would highlight it in red, and so it made it pretty obvious when something had blown up.
that easy to do because it was a BPMS sort of container, or was it? Can you do that in anything?
Yeah, we could have done it anywhere. I mean, it was all within code that we controlled, if you see what I mean. We had a kind of a sort of single class that did all the SOAP interactions and decorated them with various things and did the performance measurement on them and so on like that. So actually adding just a kind of a bit of intercepting code around that just shoved the request in and then got the response out at the end. Yeah. Yes. Yeah, well, the recording was switched on. Actually, the admin UI was turned off because we obviously want real users looking at the admin UI. But some of the bits were kind of still switched on in the background. So it was possible. For instance, the metrics, it was possible to get out via JMX as well as via the admin UI. So you didn't need to be logged into that. No, it's the JMX they're okay with, but we did turn off the admin UI in production. A lot of this stuff we did kind of under the radar a little bit. They kind of everything seems to be going okay, so they left us alone. And we didn't we try not to do anything that was going to draw too much attention to it. They knew about it, they'd seen it, but I think they maybe hadn't really sort of ruminated on the implications of it. So we toggled it off in production and. Everybody seems to be happy.
Instead of doing an instrumental client, we ran a proxy. We ran a set proxy on the same machine on a separate port, and that just logged every request and response to rotating log files. So then people can dig into that.
Yeah. I guess if you have less agency over the code, then that's probably a good thing to do. So another thing we did was kind of, as I say, we wanted to make sure that as best we could we were influencing sort of driving a kind of reduction in the overall cycle time. Getting stuff we were doing through to a completed state, and testing was nearly always a bottleneck. So one of the things we kind of decided fairly early on was that we need to try and avoid letting the testers see the sort of obvious bugs. Things that as a developer you get a bit blind to and you don't see necessarily, but the testers within 2 seconds of opening the page kind of spot and send back to you. We kind of thought that just the process of them logging a bug and then having to retest it again the next time and all that kind of stuff was just undue pressure on them. So we sort of said, we'll, in addition to doing a code review as part of peer review, we'll do an exploratory test. So we had this kind of list of gotchas that formed a test charter, and that kind of evolved over time based on the kind of things that we were regularly doing wrong, which obviously changed as we got better at certain things and as we started attacking different parts of the problem. So there's things like when we inherited this early code base, we were often finding that you'd press the back button and you'd get the do you want to resubmit this form, or the form stickiness wasn't working properly, and there are all sorts of little annoyances like that you could easily miss. When you're working in a sort of messy copy and paste heavy code base. So we had this kind of list of things to go through and do an exploratory test on, and that was hugely beneficial. Before we'd really got the code base into a good place, that gave us a really valuable sort of covering strategy actually while things were in a real mess. And I kind of think that was probably almost more valuable than investing the upfront effort in automating tests, because it was a lot cheaper to get started that way. We could do some feature work and reassure the client that we weren't just noodling around in the background, but without further screwing things up. So this is something I'd definitely expand on in the future. I think actually being a good exploratory tester as a developer is probably a good thing to be. There was no demo environment. There was this poor group of users somewhere over the other side of the country who are going to get this thing sort of dumped on them after 8 or 9 months of kind of unvalidated work, and they'd never seen it. And there was one of their managers was sort of periodically sent over to the office over here and kind of got a little look at a kind of static mock-up of it, or would sort of talk through some wireframes and so on like that. But there really wasn't much in the way of gaining real feedback. And the security regime was so strict there. I think even if they had a demo environment, it would have taken them a year to network it in such a way that they could see it from their own offices. So the solution to that was because we'd done all this stuff to kind of allow hermetic testing, we just baked the whole thing down onto a zip file and a USB key, and would then just copy it onto this guy's laptop whenever he came to visit us. So he'd take it back and demo it to people on there. Sham again was really good for this, because actually when he logged into it and said generate data, get something moderately sort of realistic looking. And actually, based on the feedback we got from that, we managed to delete a whole feature from the app, which the users at the other end said, "We don't need this. We'll never need this. Don't you realise you can just do it there?" Oh, okay. So yeah, we deleted a whole sub workflow, which was quite nice. So that's about it in terms of stuff that we did. Did it work? How well did it work? We didn't end up working weekends. Everyone else was working pretty much every weekend throughout the entire time. So we kind of took that as an indication that we were doing something right, at least. There were a few cases where very, very late on there was some sort of bad assumptions that got revealed, and we had to make major changes to our code base to accommodate them. So to give an example, there was an identifier that we were using as like the identifier for the main kind of entity within this system. Because we'd been assured that it would be present throughout the entire life cycle of this thing, and then sort of kind of a few days before the cut-off for this major release they wanted to do, they said, "Oh no, actually, it doesn't exist in the first state for this thing. It only gets added kind of a few steps down." So we, as I say, we use this everywhere. Practically every page depended on this identifier being there. But actually, having invested so much in I suppose, mainly in the basics. Having a good robust suite of tests and a good CI setup. It only took like 4 or 5 hours to, even though it was a sort of 80 file change I think we had to make in the end. It sort of took 4 or 5 hours to do it, and actually didn't really throw up any major problems, which was good, because I think everybody else who had to react to that change kind of started getting the fear and. Throwing out these wild estimates of, weeks of effort to sort it out. Actually, the downside of that is that there are a few other similar cases where things just got missed. And we ended up being this sort of tech debt magnet, where they sort of go, they start with the team that actually really should have owned the problem when something like this came up and said, can you fix it? And they go, no, it's going to take 4 weeks to do that. So they go to some, mid-tier service team and say, well, can you do something with this? And they go, no, 2 weeks. And then they'd come to us and say, well, it doesn't really belong in our layer, but we could probably do it in a couple of hours. And they go, right, you do it then. So yeah, one of the outcomes of that was we had the most amazing date parsing setup ever. So we got, I think it was at last count, 6 or 7 different date formats in different places from the SOAP layer. So we ended up with this thing that just kind of ran through every format known to man until one of them worked, and then that's the one that would get received, and it meant that nobody else ever had to change their date format, or indeed actually store them in a date field in the database was the other thing we found out. This is probably my favourite bit of feedback. We found out that in 4 separate PMO meetings, someone kept bringing up the fact that there's something wrong with the reporting around the UI bugs. We can't find them. We keep changing the filters. We've gone digging around in their project, and there's just the bugs have just gone missing. What's going on here? And I think they spent some time sort of root causing this. They didn't come and talk to us at all. They just spent time in their ivory tower, sort of digging around in Jira, trying to figure out where all the bug tickets had gone. And there weren't any. We'd get the odd 1 or 2, and we'd fix them, and they'd go away again. So that was hilarious. It didn't even occur to them that it might be something that we were doing in terms of our process that meant there weren't any bugs. It was just assumed that because everybody else had hundreds of them, and they'd had to, at one stage they added 8 weeks onto the end of a phase just to fix these mountains of bugs. And well, what are we going to do? Some things we couldn't fix. Some things sort of persisted in not going so well. So. The kind of semantic aspects of integration were, persisted in being a pain. So there were lots of problems around, the kind of things you can't describe about a service easily in a you know, a WSDL document or whatever. You know, things about you can do this when the thing's in one state, but you can't do it when it's in another state. Or, you know, this will be true when, you know, when these things have happened beforehand, but not before. And we were tripping over these things all over the place, and this was partly because the testers didn't have a good way to get data into the database. Basically, they pretty much typed it in a SQL client or loaded it in from a spreadsheet. So they were often as much in the dark as we were about what the sort of valid sets of states were, and things like this ID problem ended up surfacing very late, precisely because you know, there was just no you know, there was nothing that was making that explicit. And that was kind of tricky, you know, without an environment to test in, and without stuff upstream from us being fixed, you know. So more realistic test data generation, we were always going to kind of fall over that. You know, the manual testing was always a bottleneck, and although we sort of tried to develop a bit of a trust relationship with the testers and say, look, you can do less because we're pulling a lot of this testing upstream. We didn't really get there. I think they were used to working a particular way. They had a separate line management structure and you know, a very sort of old-fashioned way of doing things. And they kind of refused to trust that any of the tests that we were writing were really, you know, were really going to do the job. So there was a lot of duplication. You know, they'd retest something manually, and then the automation team would write another automated test that did virtually the same thing. And all of this sort of contributed to, you know, stuff queuing up behind. You know, behind the testers, which was a shame. And you know, we kind of thought maybe if we get in there and we sort of you know, we get a good rhythm going, and we show that if you focus on quality and if you focus on the technical practices, then you'll get fast and you'll get better. Then, you know, maybe it'll start to infect other people a little bit. You know, we might be able to persuade some of the you know, the people running the thing that this is a good way of working, but. That didn't really happen either. I think, as I say, we were perceived to be some sort of anomaly in the bug reporting system rather than continuous delivery practitioners. So there you go. What was the excuse? Well, as I say, I think they believed they had a reporting problem. They thought there must be bugs somewhere, or maybe if it wasn't a reporting problem, that just the testers weren't doing a particularly good job. And you know, various. I mean, I've seen this excuse a lot actually, but you have this strange bias away from giving attribution to teams for doing something well. So if something is difficult and, you know, a doomed project, and you do your best but it fails, then it's because you're incompetent, and, you know, you get beaten up for that by your managers. But if something goes well, then it's because it was easy. It's quite common to find that there's nothing you can do to get any sort of positive attribution for things. You know, it's always because of something else. And I think there was a little bit of that. I think you know, once or twice there were sort of throwaway comments made by the program manager about, well, of course your bit's just really simple, isn't it? So, you know, that's just kind of why.
If I understood correctly, your CI was around service mocking, for example. So when it went to do you have a different stage where it was actually talking to real services, and would you have any problems, or did you write any separate kind of tests which were actually handling those kind of services?
So other than for us personally, within the sort of boundaries that we controlled, we weren't able to do that. We didn't have access to an environment where we could do that. As I say, we embedded some integration tests into the admin UI, which meant that sometimes when no one else was on the test environment, and, you know, when everyone was in a good mood, you know, you could press the button and run those. But it certainly wasn't regular, and there wasn't a CI server running that. As I say, there was this other automation team who were writing you know, end-to-end tests. But it was amazing how little interaction we had with them, actually. You know, they just seemed to kind of get on with it, and that made me really suspicious. I kind of thought, you know, I can't believe it's this easy for them. I know what it's like trying to write Selenium tests against big, slow, lumbering, buggy, you know, sort of multi-tier systems, and I would have thought they'd be feeding back to us a lot. So that kind of made me think that there was some. Yeah, well, fortunately they were programming at least, but yeah, it wasn't far off that. And it's just that they were kind of slightly mindlessly transcribing what the manual, you know, the manual testers had these huge.
Did have an environment. It's called production.
Yeah.
In theory, if you had a service that tested in isolation and it was perfect, then you can have these UI tested with stubs and it was all fine. When they all come together, there should be no bugs. Did you find that as a scenario?
I was like, no, not at all.
What was the problem? I mean, why was it not?
As I say, the main one was semantics. So there were things that we believed to be true and that looked like they ought to be true based on a WSDL document we were looking at, but would then turn out not to be true in certain circumstances. So in certain states of the system, things would cease to hold. And it was impossible to find those out until someone had figured out how to put realistic test data into the database in a realistic environment, which didn't happen very often.
When you're in that kind of situation where there's no integration environment, you've only got production, that's probably the best thing anyway, because the integration environment won't be anything like production, right? Because the third parties who talk to it aren't virtualized. They're running on a single server somewhere. So it's updated very infrequently, and the only real thing like production is production.
Yeah, I mean, there was only one environment pre-production which had all of the real systems in it, if you see what I mean. Everything below that, and there were sort of two test environments between that one and us, which had a lot of stuff mocked out using sort of SOAP UI or something else. I'm not sure what. The big problem, I mentioned there was an ETL process that was feeding the database. I mean that was a big source of problems because the team delivering that were very late, and the tool they were using wasn't really amenable to automation, so we weren't getting data in there by regularly running the ETL process that was actually going to be feeding the thing in production. As I say, even in the environments that were supposed to be realistic, the one thing that wasn't there was the process for getting data in that was realistic. So it was still possible for stuff to end up in states that were impossible according to the constraints of the real system. And yeah, and we weren't allowed, within 100 miles of that.
The one thing that you expect to give you is a service that...
You'd expect it to be pretty difficult to not do that, wouldn't you?
Well, that was what we couldn't find standards, had it. But we ended up going with off-duty, so we managed to deploy to a production environment before the switchover where we could run smoke tests which were hitting live services, because it's the only environment worth testing.
Yeah. I'm sure we would have loved to have done that if they'd let us, but as I say, we couldn't even get an SSH tunnel onto the lower test environment. So getting near production was a kind of, don't even bother trying kind of situation, which was didn't make life any easier. So I'll whip through these last bits. I know I've been going on about this for long enough. So kind of stuff for next time, or if we could go back in time and do this again, that we might have done. So we kind of inherited this app that was being built was using J2E container security, and we kind of thought it kind of works okay at the moment. It's one of the only things that works okay at the moment. We've got nastier things to refactor, so we'll leave that alone. And it kind of persisted, and it became a huge pain because it was the one thing that was functionally that was just different enough between our local environment and any of the environments that we deployed into that we were tripping over it. I mean, although the J2E spec is supposed to be kind of fairly prescriptive about how these things work, it's really not, or at least the implementations of it are pretty sloppy about how they how they go about it. So we were tripping over that a lot, and there was a whole load of stuff around things that J2E doesn't specify. So we were kind of having to go around the side of it in order to do things like password expiry and quite basic stuff like that you'd expect to be bread and butter for most applications. So there's a lot of painful kind of debugging stuff in other people's environments with their permission kind of in the evening when they'd stop using it for an hour type stuff, which actually Chris over there bore the brunt of. Mocking it out for testing was far harder. If we'd been able to stick our own kind of login shim in there, a lot of this would have been a lot easier to mock effectively in the local environment. So that's definitely a no-no for next time, as if it wasn't anyway. As I say, we kind of shoved everything into unit and functional test down into our on commit build, which was was good in that it forced us to run it a lot, rely on its feedback, but the build time did get a bit on the high side, and when you let the build time get out of control, you start to slip into slightly bad habits sometimes. You take shortcuts. You run just some suites within the whole test suite rather than the whole thing because you think you can get away with it. And sometimes you kind of tell yourself you don't really need to write a new test because, oh God, I can't really be bothered to run this lot over again. So it creates a bunch of kind of bad biases in you, and I think they're probably best avoided by, aggressively managing down your build time. And a big part of that was that we didn't make it work concurrently immediately. And sort of concurrent testing is one of those things like internationalization, where if you try and add it on afterwards, then you just hate yourself from a few weeks ago. For not doing it in the first place. So I think a definite lesson is just assume that you're going to want to do it concurrently right from the outset, and make sure that you're not shooting yourself in the foot. I think it's sort of in practical terms that one of we overused Selenium. I mean, that was a that was a big problem, and it originated from the fact that was the only way to get any reliable kind of tests around the original app. But I think we should have reduced our reliance on that over time, and we didn't. We could have done things like embedding JavaScript tests within pages that had lots of JavaScript validation on, and not relied on kind of full walkthroughs of the app to do that. That would have sped things up. We were using Grails, which is a sort of monstrosity of kind of dynamic Groovy on top of Spring. It takes forever to start up, and as a sort of countermeasure to that, it has this kind of hot reloading mechanism which doesn't work. So you kind of think, oh, I'll just change this, and it recompiles something, and then it spews out log messages at you, and then you can't trust your test anymore, so you restart it anyway. So we lost a lot of time to that as well. I think the startup time of the framework you're using is a bit of a game changer, actually. I think if you pick web frameworks that start up really, really quickly, then you've got a whole raft of testing patterns available to you that just you can't do in this kind of setup. I previously built stuff with DropWizard where you can just use a JUnit rule to bootstrap the app kind of within your JUnit test case or whatever. And it happens so fast that you can do that on every test class or every test case if you want to. And it allows you to isolate your tests well, means that you're guaranteed to start with a clean state, all that kind of stuff. Yeah. Yeah. Although the interesting thing is, it's a much slower web server than Jetty, or at least for the cases I've tried it in. I did a kind of scratch refactoring of WireMock to use the standard HTTP server, and the WireMock test suite was quite a lot slower afterwards, even though the startup part of it was a lot quicker. So I think it kind of depends on your workload. I'm sure there are some where it's faster overall. But yeah, it's certainly worth optimizing these things and caring about how long they take, because it can testing when you can start and stop stuff really quickly is just so much nicer. So yeah, kind of as an extension of that, I mean, we'd obviously pick a wire protocol which is supports loose coupling and independent evolution of bits of the stack. Again, hopefully that kind of goes without saying really in a CD crowd, but REST is an obvious choice as a protocol for doing that kind of stuff. But if you're doing messaging, there are good and bad ways of doing messaging design that can enable or disable this kind of thing as well. So picking something that at least supports minimizing the coupling between systems so that they can be released independently of each other. As I say, small framework for fast startup and small footprint. I think deploying into big J2E containers is just is passé. I can't see any good reason to work that way anymore when you can just bake your web server into your app and just sort of ship a single executable binary, or that plus a config file. And again, I've done this with DropWizard in the past, and the overhead sort of if you're doing sort of DevOpsy type stuff, if you're automating deployments, the overhead of getting something working with that is so much lower, and there's so many fewer moving parts that can go wrong. Whereas trying to automate a sort of big iron J2E container to do that sort of stuff with all of the states it goes through and all of the sort of cul-de-sacs you can go down is it's just you waste a huge amount of time for not very much. And I think now that we tend to go down the route of deploying single applications into separate VMs or separate containers or whatever. It's rendered a lot of the benefits of that kind of multi-tenanted architecture completely redundant. So completely ditch that and embed Jetty or embed Netty, or as sort of myriad of other options. I kind of already mentioned this. Minimise the need for browser-driven tests. I think actually, actively architect for a system which is which is testable without having to drop down into the browser all the time. I mean, Dan Bodart writes and talks about this a lot.
So was it that you had a lot of UI side behaviour you wanted to exercise that you could have exercised with unit tests, or was it that you were exercising a full end-to-end system and could have written API tests instead?
One bit of history I didn't give actually was there was a prototype, kind of JavaScript and HTML and CSS only project which had been built kind of ahead of us arriving as just kind of a UX prototype. And the way the project had kind of been kicked off is that the JS and CSS and so on was being used from this project and kind of generated from SCSS with and whatever in Grunt, and then we were kind of copying it into the project, and quite a lot of the app had already been done this way, and we ended up inheriting that as a process, and there were no tests in the JS within the prototype, so it kind of meant that we, as I say, when we bootstrapped our testing, we just wrote WebDriver tests because that was the only way we were really confident in it. But then we probably should have backed off and found got much sooner to a better testing strategy for the JavaScript that was in there, and reduced our reliance on Selenium. Tested tested a lot more without a browser. I think that would have been a lot faster. Always difficult to persuade your client of a good time to do stuff like this. Where you have to put some sustained effort into it. You can't just you can't easily drip feed it over. It's kind of difficult to make the case for it. A lot of the stuff I've described that we kind of did under the radar. But I think we kept looking at that and thinking, we can't really do this without people noticing that we're not working on features this week. So that's the best excuse I've got to offer for why we didn't do that. So that's more or less it. I think if you take away one thing, don't let the lowest common denominator in your environment drag you down. You can still carve out a niche and find ways to improve at least your own niche and actually hopefully improve things for the people around you as well, by sticking to your guns on these things. And it's worth persisting with it, if only so you don't end up working weekends for 3 months on the trot. That's about it. Thanks. Should we go for any final questions before?
Yeah, I was going to say we have some questions. What we'll do is we'll use the mic for these, so just we can pick it up on the video. One thing I forgot to say before was big thanks to Equal Experts for hosting us tonight. Been really great. Thanks. So we've got. I think you were just about ahead.
Cool. Hi Tom. My question is about earlier on. You said you failed to influence people outside of your team or other teams or whatever. If you could do it all over again, what would you do in that regard to try and change that?
Oh God!
Or
no one asked me that.
Was that never in the remit?
It's something we always wanted to do. I think we thought we'd get in there and as I say, first of all, try and demonstrate what good practice, at least in our opinion, looked like, and then find ways of making connections with the right people at the time. It's tricky, really. It was one of those places that was set up to remove the real decision makers from the hoi polloi as far as possible. So they were just never there. I think they worked somewhere else in the building, but we didn't know where, and we couldn't. There was no kind of bumping into them in the lift or anything like that to kind of kickstart conversations. So, and as I say, the second problem was that I think they'd been doing things this way for such a long time that the idea that it was even possible to do it differently was kind of outside of their, it violated too much of their belief system.
So you're saying I shouldn't expect to see many of them at the next London Continuous Delivery meetup?
I think that's probably a safe bet. Yeah.
Let's find out. Is there anyone who's been in a similar situation and had more success in that regard, or less success, or tried solving the problem in different ways? So I personally can certainly relate to a client where you're kind of just sat there doing stuff and you're like, where's the client? Where are they in this building?
Yeah,
You don't actually know where they are.
well, I've never had it quite in that sort of that bad, but I've had instances where you quite clearly aren't getting through, and it depends on how much time you've got. It can take a very, very long time. If you're exceptionally busy and you've got a deadline to hit, and that's not your primary focus, then I'd say that there's a good chance it's not going to work. It's not going to happen. It's got to be something that you've got to be targeted and sort of focused on achieving to be able to do it. And it is a bit, I know it sounds like it's a bit of a cheap answer, but it's literally a sort of a hearts and minds thing. Getting them down the pub and evangelising and slowly winning them over.
We spent quite a bit of time in the pub actually, but somehow it didn't seem to sort of yield any real benefits beyond a stinking hangover the next day. But,
Yeah, typical two excuses. Either your project is too easy and ours is too difficult, or actually this is not the problem, our requirement gathering is the problem. That's why the whole thing is not working as expected.
This was another thing actually. We were because we were working on a UI. I think we got characterised as kind of a bunch of scruffy web developers, and because a lot of the rest of this was a big, serious, secure transactional system, that grown-ups played with, that it was easy for them to kind of characterise the split. So, well, you can do all of your all your agile stuff kind of over there with your web bits and be a bunch of hippies about it. But we do real work here, so obviously none of that stuff that you're doing applies to this. I think there's any number of ways that people can kind of compartmentalise things as a way of avoiding the idea that maybe they're not doing things the best way themselves. Yeah, I mean, maybe if we'd been in there for longer, it wasn't a long project, and if maybe if we stuck around for longer, we could have gradually, kind of stuck our tentacles out. I mean, I suppose we had a couple of pub conversations that looked like we might be starting to chip away at this enormous block of ice, but I think maybe it would have taken another year to 18 months of those conversations for us to really start actually affecting practice. Who knows?
You have to speak the same language, right? You have to speak the language of the client or the customer, and you need time to learn that language.
Yeah.
There's no good going in talking about value streams and waste and wait times. You have to actually know what those phrases are in the company and change your message to fit their message.
Yeah, absolutely. And the other thing is we were the awkward squad as well. I mean, we didn't make ourselves particularly popular with with everybody else, particularly initially, because it's kind of hard to keep it all in. When you see this Rome burning around you, you try and maintain some control over your demeanour and your body language and so on, and not give away the fact you think everyone else is acting like an idiot. But none of us are very good at that, really. So
well, it kind of goes back to your slide on what does good look like, and if you basically go in and say, well, good looks nothing like what you've got right now, and you're going to have to completely change everything. You don't win any friends that way.
No.
That's your first barrier to influencing people. So it's a tricky one.
Yeah, it takes a lot of discipline to keep a lid on it, and I'm sure we could all learn a little bit about doing that better.
Given that you didn't have access really to the right people, and that. It sounds like people were not necessarily sort of appreciative of what you did. If you could go back in time, would you actually take the gig again?
That's an interesting one. I'm going to choose my answer carefully, given who I'm in the room with. I think I would actually. I think sort of it's been a good learning experience in terms of how to get stuff done in a bad environment. I think we developed some new techniques and some practices, some things we didn't do before, which I think are going to be portable onto sort of future endeavours and will be quite valuable. I mean, it's the first sort of full-on kind of dev gig I've done with Energize work as well, where it was a sustained period of being hands-on, and I think it was good just from that point of view to really develop a sort of good team dynamic. And there's a load of ideas just for kind of enhancement to open source tools and sort of concrete things that we want to do off the back of this that will make things easier next time. So I didn't really want to lengthen the talk too much by going into this, but the test data generation thing, I think we've realised there's a whole load of variations on that we could do that would make it that could turn it into a really powerful sort of exploratory testing kind of support tool. So I think it was worth it for sort of generating this kind of thinking. I think we'll take some useful ideas and a bit of camaraderie onto the next thing that we do together, where hopefully we'll have a little bit more agency over the things that matter. I think we strongly suspected it would. We didn't know absolutely for certain, but it was the kind of place that you would have expected to have that. So none of it was a surprise particularly. Did we do what, sorry? No, we didn't get building passes for 2 months, I think. And the security was so stringent that we couldn't even go to the toilet and come back without one. We had to stand around in the hallways a lot, phoning people in order to be escorted back from the bogs. And none of the phones worked in there because the building was like a Faraday cage. Sorry? I can't say who it was. Yeah, that doesn't surprise me.
Any more questions or comments?
Related to the cultural questions, I guess. Like, what was employee turnover like there? And did you find like morale was an issue? Morale was
I think it's fair to say most people there were sort of overworked and pretty miserable. There was, there weren't really any employees. Everybody was a contractor or there through a supplier. So. It was kind of hard to gauge really. As I say, we weren't there for all that long, so I'm not really sure. I'd be amazed if many of the people there sort of were still there in 6 months or a year or whatever. I think a lot of the suppliers that were involved were the kind of companies that had lots of junior, inexperienced, low-paid people who just did what they were told and sucked it up really. So, yeah. As far as I know, no. I think it may have gone in a production environment, but in terms of actually being made available to users who get value from it, I don't think so. Thanks for having me.